Hello GameMakers, this is GameMaker Rob, and in today's episode we get a bit closer to having a fully functioning battle. We have some actor objects, some nodes for A-star pathing, and we have a system where we can generate a random list of the actors, the units in the battle, and switch between them. So let's get started. Okay, so the first thing we're going to do is we're going to change the name of our enumerator inside the create events of obj test. We're going to change it to emisc states. The reason for that is because when we get to this state here in battle, we have basically I want you to have a new state run inside this one, and it's going to be different stages of the battle. Rather than add it to this one, it just made more sense to have a second one, and the naming of this was a bit weird because it's not just about the battle, it's about having a conversation or setting up units, that kind of stuff. So I decided to rename this one so we can use the battle in a name for the enumerator for this one. How are we going to change it? Really easy. Press Control Shift and F, and then we want to type E battle states, and then under here we want emisc states. Then click on replace all. It'll ask you if you're sure. Click yes, and it will update every entry. It'll just replace this with this. It's that easy. Okay, so now if we go into actually make a new object, and you're going to call it obj animation. And if we go into the create event, we have a new enumerator, but we only have one entry, and it's called battle intro because we're going to use this object for animations, but for now we only need it for the introduction for the battle. Timer is just a timer. You'll see what it does in the step event. The way the animation is going to work is we should have two halves of one word. So the word is battle. Half of it is bat, the other half is tull, and they're just going to meet. They're going to start on opposite ends of the screen and meet in the middle. So left X is bat, right X is tull. Start wise to make sure they appear in the middle of the screen vertically. Target X basically is again the middle of the screen, but on the horizontal coordinate. So where should the text meet in the middle? That's it. And how fast should the text move per step? 4 pixels. So now if we make a step event, and we're going to say if the state is battle intro, which it should be because we're setting it as that. No, we're going to set that. Sorry, we're going to set the state of the animation object when we create it, which is going to be from the test object. But for now, we can just put this here. These checks here are just seeing, well, is left X at the target X yet? If not, then just move it along by 4 pixels. Is right X at target X? No, it's not. So move it to the left by 4 pixels. Otherwise, if right X is where it should be, then we're going to run a timer. If timer gets to a certain time, like a couple of seconds, we're just going to get rid of the animation object. This is going to be used later on. You can ignore it for now. We're just going to test the animation in a minute. So that's the step event. And then if we go to the draw GUI, we've got a new font. I'll show you that in a minute. So set the font, set the vertical alignment, set the horizontal alignment because we want to draw from the right for the left hand side, because we're going to have a point in the middle of the screen, and we want the text that says BAT to be drawn from that point to the left, and then the other half is going to be drawn from the same point but to the right. So that's why we can use the same position for both pieces of text, and then just draw the left text, change the horizontal alignment, and then draw the right text. So let's check out the font first of all. So FNT Battle Intro is a size of 72, and I've chosen Calibri as the font. If we run the game, nothing's going to happen because I've forgotten to do the test OBJ test stuff. So we just need to go into OBJ test, step event, and then minimize this. Inside the conversation region, inside this bit here on like line 25. So where it says if the map type is not battle, we're just going to say we're done. Otherwise, if it is battle, inside this bit, we're going to set the state to battle, but then also we're going to create the animation object. This bit is new. It doesn't matter where we create it because it's just going to draw in the draw GUI anyway. And then we're going to set the state of the object, animation object, to intro. This is how it knows what state it's going to be in because we're setting it here. So once you've got these two lines down, we can minimize the region and we should be able to run the game. Move to the battle, press space, we're done with that. Get through the conversation, and then this is the animation. Amazing. Okay, so if you make two new objects, the first one is going to be called OBJ actor, and the second one is going to be OBJ node. OBJ actor is going to be mainly used for the units, so for the player and for the enemy. I might use them for animations like fireballs as well. Not sure yet, but I'm just calling it actor just in case it's not specifically for units that we use it for. And OBJ node, this is going to we're going to have a node for every cell, and we're going to use them for pathfinding. We're going to use an A* algorithm. I'll put some links down in the description box if you want to have a read up about what A* pathing is. Knowing how it's supposed to work will help you a lot. So, I'd definitely recommend taking out 10 minutes to read some of the links that I put in the box. But I'm also going to briefly describe what's happening when we do the pathing, which is going to be in the next episode. For now, we're just going to set things up for that. So inside OBJ actor, we just have a create event for now, and we're going to have two variables, grid X and grid Y. We haven't set grid size yet, but just type this for now. Basically, it's going to be on the grid, so on DS terrain data, what X coordinate is it at, and what Y coordinate is it at. That's what it's going to be used for. And we're not going to have the actors, the units, draw themselves. That's why they don't have a sprite. We're going to say, okay, is there, we have a double for loop that draws our terrain right now. And we're going to say, okay, does this cell have a unit? If it does, then we're going to draw the unit. So we're just going to do it that way. And then in OBJ node, again, just a create event, and we have one variable called neighbors list. This is going to be a list that stores any IDs, instance IDs of any instances of OBJ node that are next to it. So if we say this is node 0, it's going to be adding 1, 2, 3, and 4 to it. If there's a 5 there, we're going to ignore it. We're only interested in the ones that are adjacent to it horizontally and vertically, like this. So at most, the neighbor list will have 4 IDs added to it. If the node is in the corner, like this, it's only going to have 2. I learned about how to do this from Sergeant Indy. His explanation is going to be a lot more in depth than mine's going to be. So I'll put a link to his videos in the description box as well, just in case you're interested in seeing that in a more in-depth tutorial. Okay, so if we go into the create event of OBJ test, we've got a couple of things to add. So here's our new enumerator. We're just going to call it eBattle. we have not ready, so this is going to be used for setting things up or waiting for things to be set up before we can start. A set up turn order, so you can organize the turn order of units however you like. I'm just going to have it randomized for now because I don't have any particular stat that I want to use for it. I might add a stat called initiative and then use that. You can use any combination you want, but anyway, I'm going to have a random order for every turn, so every unit's going to get added to a list. The list is going to get shuffled, and then they're going to take their turns in order of how they appear in the list. Once the list is empty, I'm just going to generate a new one. That's what this is for. This state will generate the list, and then while the list size is greater than 0, we're going to use this state. So for testing, all we're going to do is we're going to press enter, and it's going to take us to the next actor, and we've got a script that's going to center on the actor as well. Once the list size is 0, it goes back to setup turn order. Actor taking turn is after this state's happened. So if the list size was greater than 0, grab the new current actor, and then if they're taking their turn, that's the state that's going to happen. Once the actors finish their turn, it'll go back to next actor. Node grid. So rather than adding 2 new enums to our etal data, let me just show you that one so you know what I'm talking about. So at the moment, where are we? We do Control Shift F, etal data. Sorry, it's in the editor create event. So in every cell of our grids, we have a list that holds information for all of this. Rather than adding 2 new things to this and having to change other things, I figured it would just be easier to have a grid that holds the IDs of the nodes and a grid that holds either no one or an ID of a unit or an actor. So that's the reason I've added 2 grids. I try and use as few grids and objects and sprites as possible, but sometimes it's just easier to add a few new ones than changing a lot of other things. So that's what these are for. Node grid, actor grid, turn list. So this is going back to what I was talking about when we set up the turn order. All the actor IDs are going to be added to this list. Then it's going to get shuffled. Grid size. So when we create nodes and create actors, we're going to be placing them as though it's being placed on a 2D grid, and the actors are going to move around as though they're on a 2D grid, but we're going to draw everything in isometric. At the very end, when we've done all the code, I'll show you what it would look like if we were doing it on a 2D grid. But in order to make sure that we can work in the realm of a 2D grid, that's what we're going to have a grid size for. Every cell is going to be 16 by 16. This is the state that's going to run inside this state. So once we're in battle state starts to run. First of all, it's going to get set to not ready, and then all these 3 things will happen afterwards. And current actor, so next actor is going to be setting this variable, and this is the actor that's going to be taking their turn basically. Okay, so now we're going to do the bulk of the coding in the end step event. We've already done these 2 lines in conversation. So in setup battle, right underneath where we clear the spawn tile list and mandatory list, we're going to be having more than one battle in the game. So every time we have a new battle, we're going to be making new nodes. So the first thing we want to do before we set up the new battle is we want to get rid of the previous existing nodes. Each node is going to have its own list, so we have to destroy that as well to make sure we don't have a leak. And then we're going to get rid of the node itself. That's what this is going to do. Quite straightforward. Then we need the node grid and actor grid to be the same size as DS terrain data, because our maps, the width and height of our maps can change. So that's the first thing we're going to do. And then inside our double for loop, I made this bit here. This used to just be a comment, but I made it into a region. So this is what the region contains. There shouldn't be any new code in there. And because this is a local variable, I didn't want to change it into an instance variable because we use a unit quite a lot for different things. So what I've done is I've just done it again here so we can use it outside the region. So this is a new line. So what's happening is we're inside the double for loop. Every cell's being checked. If on that particular cell, that list has a unit that isn't empty, so it's going to be a fighter or a mage or something. If that's true, then we're going to have this block of code. So we're going to have a region called create an instance for this unit. So actor is going to be an instance of obj actor. The coordinates where it's being spawned is just going to be xx times grid size and yy times grid size. And then with that particular actor, we're going to say its facing is whatever the list data says its facing is, and its actor ID. It's not going to be an instance ID. It's going to be whereabouts in our character classes and character CSV. Whereabouts does it appear? So, is it number 18 or is it 14? That kind of thing. So that's all it's for. Because we are saving the facing and this stuff to the actor itself, it means we're not going to be using the list for this bit inside the battle itself. We also want to know whether this actor is player controlled or not, because we might want to have some characters on the player's team be AI controlled. So that's what it's for. I guess we could even have an option for the player to say, okay, well, I just want the AI to play the game for me, and I'll control one or no characters. So that could be a fairly easy option we could do. So once we've done this region, this last here, so we need to add the instance to the actor grid wherever it should appear. Otherwise, if there was no unit, if this is false, then this is going to run. So if there's no unit, then just set XX and YY inside actor grid to no one, because there's no actor there. Then we have our create nodes region. Pretty simple. For every cell, we're going to create a node. Its position is going to be XX times grid size and YY times grid size. And it's an instance of obj node. And then again, very similar to how we added the actor to actor grid, we're going to add a node to the node grid. That easy. The reason we have a yellow mark here, by the way, is because I haven't used this variable in any part of the game yet. So it's only the yellow mark says it's only referenced once, because all I've done is set it up. I've just initialized it. That's all. So let me just minimize this now. So after setup battle, we have a new region called fill node neighbor lists. So we're going to run a second double for loop. That's going to be the height and width of node grid. We're going to grab the ID of the node from the node grid. We're going to create a list for this particular node. We're going to say, okay, if the node isn't at the left edge, then there must be a node to the left of it. So add that node to the list. So this is the node to the left of it. If the node is not at the very top of the grid, then YY will be greater than 0. And this is going to be the node that's going to be above it. So add that one to the list. If the node is not at the very far right of the grid, then there's going to be one to the right of it. So add this one to the list. And finally, if the node is not at the very bottom of the grid, then there's going to be one below it. So add this one to the list. And then we're just going to say for this particular node, this one here, its neighbors list is going to equal the list that we've created here. Okay, so now we can minimize this region. So in add from reserve, all we've done is we've added this line here saying battle state, our new state is not ready. And then there's a couple of states inside this one here. This is a new state, new area. So if we are of the state in battle, if battle state equals setup turn order, then we're going to add every instance of obj actor into turn list, like I said. And then we're going to shuffle turn list, which will give us a random order. And then we're going to set the state to next actor. If the state is next actor, the first thing we're going to do is make sure the size of turn list is greater than 0. If it's not greater than 0, then we're going to set the battle state back to setup turn order, and this is going to run again. If the size of the list is greater than 0, grab the next actor. So whatever is first, whatever ID is first is going to be saved in current actor, and then we're going to delete that entry from the list to reduce the list. Then we're going to have a new script, very similar to center on speaker. This is center on actor. And then after the script, we are going to set battle state to actor taking turn. So if we check out this new script, we are just passing it one variable. We're going to pass it the actor. This is the instance ID of the actor we want to center the camera on. We're going to use the actors grid X and grid Y to get the isometric coordinates. And then we're just going to use this line again to center on the actor. So a lot of this code is a copy paste from this one. So I just copied these 3 lines and then changed the XX and YY to these. And this is the same. I've also made a new group called battle scripts because we're going to have quite a few. So inside game scripts, I've got battle scripts, and this is going to be the first one. So that is the next actor region. So inside actor taking turn, all we're going to do, just to test to make sure the turn order works, every time we press enter, we're going to set the state to next actor. That's going to get the next current actor and delete it from the list. So that's how we're going to test it. And that's it for the end step event. Before we do anything else, before I forget, let's go back into OBJ animation, and we want to have this line here in the step event. So if timer is greater than room speed times 2, destroy itself, and also set OBJ tests battle state to set up turn order. So that's what's going to start the process happening. Otherwise, battle state is going to be not ready still. Okay, so now we can go into the draw event of OBJ test. So inside draw cell, we've got a small change in the unit region. So this code here, we just want to make sure the state is inside conversation to run this code, because we're going to be drawing the units a different way. So region battle unit. If we are, this whole region is new. If we are in the state of in battle, we're going to grab actor from the actor grid. This could be no one, or it could be an instance ID. If it's not no one, then we're going to say unit equals actor.actor ID. So it's going to be 0, 1, 2, 3, 4. Facing is going to be actors facing, and we're just going to use our SCR army screen draw unit script to draw it. Might as well. And also we're going to draw our ISO select sprite above the actor if the actor is the same as current actor, just to make it obvious of whose turn it is. And that's going to be it for the draw event. And then finally, if we're going to draw GUI, just so we can see the turn list being populated, we can use this little block of code here for that. If we run the game, and let's walk to our battle, press space, enter several times, get our battle animation. And you can see we have a list in the top left. These are all the IDs of the actors that are next to go. So 3-6 is next, then 3-4-3, 17, 3-4, etc., etc. Press enter, it'll focus on the next one, and the list will reduce in size. Press enter again. And we have a new list and a new starting character. So that's how our turn order is going to work. Okay, cool. So there's one other test, well, two other tests, but the next test I want to do is I want to go inside the draw region, and if we're in the battle state, let's say check list size of nodes. Testing. We're going to say node var node equals node grid x x y y. Var list size equals ds list size node dot neighbors list, and then we do we need to set draw coordinates? Maybe draw set h align. We want vk, no v. I can't think how to do it now. HA center. FA center. There we go. Draw set V align, FA middle. Draw set color C white. And then finally draw text, draw X, draw Y, string, the size. So this is going to display the size of all of our lists. Let's run the game again. The size of all the neighbor lists for the node, sorry. Press space, lots of enters. And then you can see in the corner, the bottom left corner here, there's a 2 because it's only next to 2. All the ones along the edge have 3. Corners have 2. And if they're not on the edge or corners, they're all 4. As long as you have that, then you've done it correctly. My next step was going to be to show you a 2D representation of the actors being spawned onto a 2D grid. I think I'm going to do that at the start of the next episode, because then we can show pathing working at the same time in 2D, as well as draw it in isometric at the same time. Anyway, I hope you enjoyed the video. I will catch you next time. Bye for now.